Good afternoon, everyone. I'm Cassie with AABC, and I'd like to welcome you to today's Tab Talk webinar. I also want to thank our sponsor, Integra, for supporting today's session. A few items to cover before we get started today. Our presenter will hold questions until the end of his presentation, but we encourage you to submit your questions at any time using the Q&A button on Zoom. If you happen to experience any technical problems during the webinar, please use the chat function to inform the panelists so that our producer, Will, can assist you. This presentation is being recorded and it will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar today will receive a certificate of attendance sent to their email within 24 hours. And finally, if you're a certified TBE or TBT, your CEUs for attending this webinar will be automatically uploaded to your respective portal after the webinar. Today's webinar is Mastering Stairwell Pressurization, a tab-centered approach. I'd like to welcome our speaker for today, Eric Grunmeyer. Eric is the president of RS Analysis, LLC. In 2012, he joined RS Analysis as an apprentice, and his dedication quickly led him up the ranks. By 2017, he became a certified AABC test and balance engineer after passing the challenging TBE exam. In October 2022, he was promoted to president of RS Analysis and now is focused on growth and ongoing improvement across the organization. Eric, thank you so much for being here today. The floor is yours whenever you're ready.
Good morning and afternoon to everybody. Thanks for joining us. Excited to talk to you guys about stairwell pressurization and being able to go over um, some of the things that I have learned over the years. Um, Here are the four learning objectives that we're going to be looking at today, guys. We're going to be looking at the NFPA standards. We're going to be talking about kind of a step-by-step approach to the tab procedures for stairwell pressurization. We're going to go over some of the lessons learned and things that we found in the field that have caused failures over the years. One of the things that I want to bring up, and I'm going to bring it up many times throughout this seminar, is, even in the AABC standards, it has a disclaimer that says the requirements of smoke control testing are determined by the local jurisdictions. Guys, it is extremely important that you understand the requirements locally, right? As you go through the contract documents and understand the rationale analysis for that specific building. But it's going to be approved. Fail or pass is going to be by the local jurisdiction. They're the ones that are going to give it a passing or failing grade. And so a lot of the things that we're going to talk about today in, NFPA, and I'm going to bring in some of the IBC standards as well, is that those have to be adopted by the local jurisdiction. So always go back to the local jurisdiction, always go back to the contract documents. Those are going to give you the specifics that you need in order to do any kind of smoke control for a building. The requirements are going to be there. We're going to talk about some general standards, some things that we see in the field. We're going to talk about some engineering standards as well, and a lot of those have been adopted into the local jurisdiction, but you always need to go back to the local jurisdiction, go back to the specific requirements, the specifications, in order to see what is required for smoke control. What stair pressurization must do and why it is so important. Uh, this is a picture of the MGM Grand back in 1980. They had a fire, and my mentor, Michael Renovich, has always said, if you're ever going to be in a fire, you're going to want to be in Las Vegas. Why is that? Because out of this fire came national standards for smoke control. So what they found in this fire is that 80 plus people passed away in this fire, and the majority of those, I think they talked about only about 15 or 16 passed away from actual exposure to flames. Everybody else passed away from smoke inhalation. So it is extremely important that as we found out with this fire and moving into the standards, is that smoke control is is the primary factor that we're trying to look at. And so when we're talking specifically for stairwells, what are we trying to do? We're trying to keep the smoke out of the stairwells because the stairwells is the egress in an emergency. So if we have an emergency, we have a fire, the stairwells are going to be the escape route for the majority of the occupants. So we're trying to keep smoke out of there. We're trying to keep that clear so that they have a clear path to get out of, the fire. The other things that we're going to be talking about too is keeping doors operable, and that pressurization should never make it too difficult for anybody to open the doors into the stairwell or out of the stairwell. And we're going to talk about also just worst case scenarios, right? Open door conditions when a fire happens, what happens when you open a door into a stairwell, in real events. They never happen under ideal conditions. And so there are many, many variables that we're looking at, when we have an event. And unfortunately, we're not going to know too much about what's going to happen until there is an event, right? We never want that to happen. We never want an event, but we do learn a lot when events happen. And so, one thing to keep in mind as we go through, kind of looking at some of the standards in the NFPA and IBC is that this happened in 1980. NFPA wasn't established until about 1985, and I think 1987 was the original kind of publication of NFPA standards. And so we're talking about a short time, really, in the timeline of, building buildings. We're only talking about 40 years, which we've actually had a national standard looking at smoke control. And that's important because it's a very short time. And, we look at, things have evolved over that time. We've seen a lot of different things enacted and brought into those standards, much like what we see in ASHRAE 170 in hospitals. Those change, every couple years. It seems like we're trying something new. We're looking, maybe we reverse back to something we did a while back. And so we're still learning, we're still growing, and we have to keep up kind of with what are those standards looking at. And so once again, going back to the specification, going back to that site specific contract documents, construction documents are going to be imperative to know what we need to do in these buildings in order to pass smoke control. So the NFPA 92 is a standard for smoke control systems. This is more of an engineering document, if you will. It's a kind of a BOD, a basis of the design of what engineers need to be looking at as they're designing smoke control systems. We are going to be focusing in on just for stairwell pressurization and kind of the tab approach. And so underneath just the stairwell for NFP 92, we're going to be looking at required differential pressure across doors. We're going to be talking about, door force limitations. Where is that? How far can we go? Most enact a 30-pound door force, right? But that's really broken them into three parts. It's the break of the door hardware at 15 pounds, put into motion is going to be the 30 pounds, and then all the way open for 15. So the maximum that we want to see in that whole process is 30 pounds limit. Now, there are some ADA requirements that we've seen here in California that require 15, that you can only go to 15 per the ADA requirements. And so that is now the new limiting factor in some buildings. We talk about the open door conditions. How many open doors is the system designed for, and airflow limitations. So once again, this is not the code, guys. Just like ASHRAE 170 is not a code, this is more of a standard, what we're trying to design to. ASHRAE 170 is called a standard, so we're trying to design that to that. In California here, this is what I know mostly is the California codes, but California Mechanical Code adopted ASHRAE 170 as Table 4A into their CMC, California Mechanical Code. And so we see that NFPA standards are adopted into a lot of local jurisdictions. So starting off on that differential pressure that we were talking about for each of the stairwells. They do have different requirements for sprinklered and unsprinklered systems. Sprinklered buildings require a zero point zero 0.05 differential pressure from the corridor into the stairwell. Now, we also have to take into account if there are vestibules. If there are vestibules, they do require a zero point zero 0.05 differential pressure across the corridor to vestibule and the vestibule to the stairwell. So we really need a total of zero point 0.1 cascading pressures. So depending on the type of, systems that are installed in the building, also if you have vestibules or not, it changes the requirement that we're looking at. The other thing is, this is different, and you'll see a lot of, I think, IBC, and a lot of you may work in jurisdictions that have adopted the IBC. But IBC does have a maximum pressure requirement that they don't want it to exceed 0.35. Excuse me. And NFPA does not actually show that there is a maximum pressure that we can have. It just says until you exceed your door force. And so it says you have to basically your limiting factor of how far can you go in a maximum. Yes, we've identified what the minimum cascading pressure has to be in the zero point zero 0.05 or the zero point 0.1, but the maximum really is the limitation of when do you exceed that door force of 30 pounds or 15 pounds. Now, I don't think anybody is going to be able to get to zero point 0.3 in a stairwell and be able to not exceed that door force. And so really in practicality, you're looking at, somewhere between that 0.05 to 0.15 is kind of the conditions we're going to see to set up that stairwell. Um, we talked about this a little bit already, but uh, the the uh, the door force limitations and the maximums that are set are actually by NFP 101. So NFPA 101 actually identifies the door force maximums, and 92 has adopted basically the NFPA 101. So just kind of recapping on that, as we talked about, is most jurisdictions we're going to see that 30 pounds of force, and they're going to break it up into three factors. The unlatching or the break of the hardware being 15 pounds or under, and then 30 pounds to start movement or to start in motion, and then 15 pounds to fully open. Now, I've seen this tested in a variety of ways. I've seen some local jurisdictions, the AHJ, come out, which is typically for us the fire marshal. And as long as you go through the entire motion of opening the door and it doesn't exceed that 30 pounds of force, then they're like, okay, you've passed. And so I have also seen where you reset in each of these motions where they want to see you break. If it's a panic bar, they want you to see the panic bar break under 15 pounds. You show them the force, you reset. Now they want to see it start in motion to make sure that doesn't exceed 30 pounds. You reset. And then once you kind of break that and get the full motion, they want to see that to be 15 or under. So everybody's have, ran across this with different building, you know, IORs, Inspector of Records, or AHJs that come out, they all want to see it differently, and you just work with them to say, what's practical here. So there's a lot of practicality that comes into testing of the stairwells. What do they want to see, and just making sure that you're meeting these minimum requirements. So one of the things that comes up as well is, what is the system designed to do? And so the rational analysis is usually done by a fire engineer. That's what we've typically seen. So the fire engineer looks at the building, looks at the requirements, local jurisdiction, and comes up with basically a smoke control plan. Underneath that smoke control plan has a lot of testing requirements that are done by the test and air balance, contractor. And so in that, they're looking at, okay, how many doors are we going to design the stairwell to be open at any given time? Now, this is where also, it's in theory, right? It's in theory, and more. most cases, if there's a fire, every single door of that stairwell is going to be open, right? And no system that I've seen to date can accomplish keeping the pressure at, point one, with every single door open. It's going to be kind of panic chaos, and so they design it with kind of a criteria saying you're either going to have one or two doors open, and they do come back, and sometimes they want to see while you're doing the testing, okay, if we open one door, what happens, and so can the system accommodate for that. There's been some different ways that we've seen that be accommodated. I had one instance where they did try to control the differential pressure from the stairwell to atmosphere based on a PID loop. That PID loop had to be very fast. It was problematic to say the least. Trying to maintain a point oh 0.05. I mean, anybody can, or a point 0.1. Sorry, this was this in this condition, it was point 0.1. But even trying to maintain that with the variables was very difficult. And the other aspect of this is that we see a lot of times in IBC, it's a requirement, not in NFPA, but a relief vent. There's a relief vent that we have to set at 2500 CFM. That is in place partially because they want to have excess energy in the stairwell so that when you do open a door, that backdraft damper will close at the relief vent, giving you more energy into the stairwell to keep that stairwell positive, especially as doors open throughout the process of getting everybody out of the building. So what is a rational analysis? This is what like I talked about, a fire engineer is typically the one that goes through the documents, looks at the building, and they come up with an analysis of what do we need to do? What are the requirements for smoke control within this building? How are we going to accomplish, the NFPA requirements? And they come up with a document that kind of basically shows, and this is all given over to the local jurisdiction, in our case, the fire marshal, depending on the building. Sometimes it's a state fire marshal that has to go through this plan and give it an approval. So the NFPA requires, the NFPA 92 requires that they have this analysis for each building. Over the years, sometimes we've been able to find it, especially if you're going to do any kind of retrocommissioning or retesting. Sometimes it's difficult to find this analysis, but it's important that you do. You try your best to find it because it's really going to give you how is the system designed and what are we looking to accomplish with the smoke control plan. So there is also an airflow limitation they talk about in a NFPA 92, and it's 200 feet per minute in systems where I've seen this tested in not necessarily in the stairwell application, but where I've seen it mostly tested is for smoke evacuation, and so you have to have makeup air for smoke evacuation. And so sometimes they use doors that access to the outside as their means of makeup air for the smoke evac fans. And they don't want that smoke evac, they don't want the air coming through the doors to exceed the 200 feet per minute because they don't want to create any type of turbulence. They don't want to create any type of draw where, it's going to feed the fire at all. So it's a limitation that they're trying to keep it slow as it comes in to not disrupt what's going on, but also be able to use the smoke evac fans to get all the smoke out of the area. We're not going to talk too much more about that because it really is more pointed towards the smoke evac fans than it is about stairwell pressurization. We talked about this already, but just the one kind of crossover from NFPA 92 to NFPA 101 is just that door force requirements that they've given. Once again, it's the 15 pounds to unlatch, to start movement, and to swing fully open. And we went over that earlier. So the systematic approach to tab procedures. So um, this is kind of the step by step. As you get involved in a project, what are the things you're going to be looking at? How are you going to go from each of these phases? Now, I have a Rubik's Cube here. One of the things that I've kind of always used an example for smoke control is that it's a puzzle, right? We're trying to put this puzzle together. There are different requirements that all adhere to the stairwell. As we talked about, a lot of times you're going to be having to set that relief fan. You're going to have to set the pressure to the stairwell. You're going to go through cascading pressures and setting for your door forces. And so there's this kind of puzzle that you got to put together. And so, if anybody's ever done a Rubik's Cube, there's algorithms that you can use to actually complete the Rubik's Cube. And so I've always looked at smoke control in that way um, that it's a puzzle, and there's algorithms that we can use to kind of get through it. And how does one twist and turn affect the other? Because as we'll talk about is, if you set your pressures higher in your stairwell, well, then that affects your door forces, right? And so all those things play a part. They all interact with each other. And so we'll go through this kind of step by step, kind of what to expect, what to look for, and going through the process, especially from the tab side and the tab approach. So the first thing we're going to want to do is, what is the system supposed to do, right? We're going to want to go through the documents, the construction documents, the specifications. We're going to want to look at the fire plan, or the smoke control plan, and see, what are we needing to do? We're going to want to confirm the acceptance criteria. So one of the things, that we talked about earlier was the 30 pounds versus the 15-pound ADA requirement. What is being enacted? And so those are some questions that definitely need to come up in the beginning. We like to talk about those things early on with the team, especially the mechanical team, but we also may need to bring in some of the general construction team, because some of the things that always seems to be missed in these is the adjustable door sweep. So especially if you're working with a vestibule where you're going to have those cascading pressures from the corridor to the vestibule to the stairwell, you need adjustable door sweeps. And a lot of times that is missed because they're not they're specking that, not thinking about smoke control. They're specking it because they're thinking just about, the door operation. And so those are some things that you got to talk through, make sure that they're in place, because you don't want to get to the end of this project and you go to do the fire life safety testing and go to do your Stairwell pressurization testing and realize you don't have adjustable door sweep. So there's no way for you to create that cascading pressure. So those are things we're looking for as we're going through the scope review. We had a job one time. This one made history for me, but we were going through, and we actually had, for this specific project, we had to look at duct leakage for the smoke evac fan. So yes, this isn't part of sterile pressurization, but this kind of just identifies, as we go through the document review, like what we're looking for. And one of the things that we were going up there and we were looking at this fan, and this fan was ginormous. It was a utility fan. It was um, huge, and we were like, man, that seems like a really big fan for what they need, because this ductwork went down to, I want to say it was 36 by 36 or something around there. It didn't make sense. 36 by 36 is too large. It's probably 24 by 24. And it was a really big fan for small ductwork, and we're trying to figure out what's going on. And so we went back to the schedule. We looked at the fan that was spec'd, and what had happened was the mechanical team, when they went to purchase the fan, they saw the criteria, and the criteria was 4,000 CFM per floor. Well, there was 10 floors, and they said, okay, well, 4,000 per floor is 40,000 CFM. We're going to buy a 40,000 CFM fan. If you actually looked at what the engineer spec, the spec for that fan was 4,000 CFM. And what it was that for the smoke control system, they only had anticipated one floor being an alarm at any given time. So all the other dampers on every other floor were going to close, and you're going to have 4,000 CFM for that floor. And so they bought a 40,000 CFM fan, and we ended up only needing 4,000 of it. And it was pretty problematic to try to get a fan that was spec to operate at 40,000 to work, down at the 4,000 CFM range. But those are the type of things that we want to look at the very beginning. What does the schedule say? What are the requirements? What does the smoke control plan say? So that we know what the criteria, which we're trying to achieve at the end of the project. Um, this is a huge one for us is the pre-check plan, right? As you're getting towards the end of the project and they're starting to kind of poke you about, hey, we want to get stairwell pressurization started, having a checklist, right, before you start the stairwell pressurization is extremely important. It always seems that we're getting pushed that, hey, we need to get stairwell pressurization. We need to get smoke control on the docket, on the schedule. Can we start anything early? Can we, start testing? And, you walk through the stairwells. And I mean, I've walked through where baloney cords are going down the stairwells, and every door is propped open. They're missing the glazing in the doors. The door hardware is not complete. They haven't finished the electrical. The penetrations aren't sealed. All of these things affect what we're trying to do in the sterile pressurization testing. And so they really need to be complete. And I always tell, in the beginning, when you're having those pre-meeting discussions, especially at the beginning of the project, uh, you need to bring up that really the stairwell needs to be 100% complete. That is really what, you're achieving. You're going to be the one of the last tests that happen out on site because you need finished flooring. You need the thresholds installed. You need all penetration sealed. You need all the glazing installed. You need the door sweeps on. And all of that, is affecting. You need the reference space to really be completed as well. If they have windows missing or anything else in that space, it's going to change how the test looks. And as you're going through construction, if you're testing before construction is complete, you're going to have variances that happen because they're going to complete things and it's going to change your readings. So really having that stairwell 100% done needs to happen, and you really need to work with the team to have that checklist in place to say these are the things that have to happen in order for us to get started. So here's some things that we do that we look through for our construction checklist. We're looking for integrity. We're looking for, completeness. We're looking for housekeeping. Is it clean? Or have they taken the baloney cords out? Is nothing draping through uh, the stairwells? We're looking for door installation, closer operations. Are the seals installed? A lot of times it seems that the egress door, the door at the very, that leads out into the street is one of the last things that are installed. I don't know why that is, but on a lot of our projects, it seems like they always wait till kind of the end to install it. So there's always a plywood door there. And I've been asked many times, well, can we just seal that up and can we just put some plastic over it in order to start our testing? And really the answer should be no. I've tried it both ways. I will be honest with you. I've tried to, okay, let's be the team player. Let's put some plastic up. But we're always going back and redoing a bunch of our work because we didn't have that finished condition as we just talked about. Other things that we need to have the power, to the equipment. We need to be able to interface to start and stop it, and be, where the controls, where the BMS. Now, it being a team player in all of this, really the controls is kind of outside of our scope. Whether the sequences are done and the BMS is ready and or the controls, sorry, more of the controls of the fire life safety system is ready to go because there's a lot of workarounds. We can go down, we can start the fan, we can turn it on manually, we can start doing our pressurization testing and we can do that and we can, set all our pressures, do our door forces, get all our paperwork in place just with turning the fan on locally. But when you go to do the final test with the AHJ and and typically it happens late at night, they come after hours, everyone's gone, and we go through, the sequence testing and they want to see door forces and pressures. And it's all in one though. It's a package deal. if they fail, you fail. If we fail, they fail. So it's a package deal that we all need to work together. And so keeping in contact and having a good relationship with the controls contractor is very important because you're kind of in it together, whether it's all going to be an all pass or an all fail. And so working together hand in hand, knowing where they're at, what they need, and just kind of doing some back checks back and forth to be the team player is important. Some last things, we talked about a little bit, but just mechanical readiness, are the dampers installed, ductwork, and it really where's the condition of the building. And this is the slide I had. I kind of jumped on it early, but is, once again, is the construction mechanical systems 100% done before you get started on the stairwell pressurization? I promise you, if you jump in early, you make them happy by, hey, we'll get started early. You're going to come back and do a lot of retesting because as that condition change, as they seal up the stairwell, as they do painting, as they do caulking, penetration sealing, put in thresholds, all of those things, your readings are going to change. You're going to be resetting fan speeds, you're going to be resetting doors and changing door sweeps a lot. So the next part of it, once you get through your checklist and your checklist is complete, now your stairwell is 100% ready. You're ready to kind of start the first part of the testing. For us, we always start with a passive test. We want to go through the stairwell system or through the entire stairwell and see what our baseline is. This is with the system stairwell pressurization off, and we're going to go through floor by floor, and we're going to be looking at, we're going to be taking door forces at the time. Typically, what we do at this point in time is we get the general construction team involved. We ask for whoever adjusts the doors to come with us, and we go floor by floor and we check the door press, the door forces to see if there's any mechanical issues or any hangups. A lot of times the door forces fail not because of the pressure that's being applied by the stairwell system, but it's actually because there's a mechanical issue or that it wasn't set correctly, the adjustments weren't set correctly at the beginning of the testing. And so we like to go through and see where we're at on each of the door closings. And in this condition, we have to make sure each door can open and fully close on its own. There are some limitations too on how fast it has to close. So they're looking for certain situation or certain timelines where, if you open a door fully, how fast can it close? Because what we want from a smoke control standpoint is we want the least amount of force having to be in the actual operation of it. We want that to be the least amount because when we turn on the fans, it gives us flexibility to deal with the pressure because we're going to have force applied to that door and depending on how far we have to go up in pressure, it's going to create more force. So it gives us it gives us more flexibility when we go through our testing to if that door is at the least amount of force to close. So we're looking for that. We're looking for, is it rubbing? So one of the things that we've seen in the past too is that the you know the surface at which the door is swinging on, it may change. It may have some changes in height. And so we've actually seen it rub, like the door actually rubs against the ground, which causes problems too. So we're looking for those type of things. We're looking for what is the door force, with no fan on. And then we're also, just making sure that all the other things have been taken care of. At this time, too, one of the other things is that you can start adjusting your door sweeps. So a lot of times they want to just hammer those things to the ground to start with. They're thinking, hey, we want this to like basically brush against the ground to start. And that's not always true. We like to start with at least the door from the vestibule to the stairwell to be about halfway up. So you can make that adjustment. Really, the door from the vestibule to the corridor can be all the way down. That's okay to start. And then you're going to make those adjustments to get that cascading pressure of 0.05. But if you leave that threshold or that sweep all the way adjusted down from the stairwell to the vestibule, you're basically creating uh, all your pressure drop will be at that door instead of having any kind of cascading pressure. So this is also a good time to make some minor adjustments just to make sure that you can have that pressure move from the stairwell to the vestibule. So then we're moving in. So once we go through all of it, we have our checklist complete. We've done our passive testing. All the doors are now adjusted with the least amount of pressure to close. Then we can go into our active tests. So we're now starting up the fans. We're going through and setting pressures. So like we talked about earlier, if you have cascading pressures, with vestibules, we're looking at point 0.1. If it doesn't have vestibules but does have a sprinkler system, you have 0.05. If you have a sprinkler system and no vestibule, then you're looking at point 0.1. If you set directly to point 0.1, I promise you, you will have a very difficult time getting your to every single door to hit that differential pressure. So we typically like to extend that to about 0.15. We've even gone a little bit above that so that we have some play in order to, ensure that we're meeting that minimum, because remember, that's a minimum differential pressure limited by your door forces. With 30 pounds of pressure, typically, you can even go higher than that and be okay. You could have point 0.1 across each door and you'd probably be okay with a 30 pounds of pressure or 30 pounds of force to open that door. But if you're getting into ADA requirements that require 15, you're going to want to limit your pressure as well. So now we're checking things, in this condition, do the doors fully close? One of the things that happens with the egress door at the bottom, because you typically swing out. So egress doors at the bottom typically swing out. And so when you have that pressure set to point 0.1 and that door swings out, it has a very difficult time closing. So in the past, this is also one of the things you may want to check during that pre-construction document review is what is that egress door operation? Does it have an automatic closure? So a lot of times we've had automatic closures having to be installed because the pressure at point 0.1 keeps that door open. And there are requirements depending on the local jurisdiction that require that door to close. And so if it does require to close, sometimes you're going to have to go to an automatic closer to pull that door shut in a case of an alarm underneath an alarm condition. Once we have all that set, final documentation, we're going to go back. Of course, we're going to do performance testing of the stairwell systems, mechanical systems. So just in our balance report, we're going to have amps, volts, we're going to have hertz and static pressures and all of that into our report. Underneath the closed door test as well, this is when we're going to make our door sweep adjustments for that cascading pressure, just like we talked about. So once we have the pressure set, we're going to go through and we're going to adjust our door sweeps to ensure that we have that cascading pressure in meeting those differentials. Once those pressures are set and we don't want to start testing under an alarm condition until we have our pressure set, then we'll go through and we'll start doing our door force checks. So we'll go through and start doing our door force checks. We'll record those, make sure that they're not exceeding the maximum amount of the 30 pounds. One other thing to keep in mind is that in IBC, I believe, and if it's adopted, they do require a relief of 2,500 CFM. Now, I've been in situations where it is required as a relief of 2,500 CFMs, and I've also had where it's not required, either grandfathered in or out of state where they don't have that requirement. But depending on whether you have to set that 2,500 CFM of relief at the top of the stairs, that's going to come into play when you're setting your pressure. So you're going to have to set that 2,500 CFM of relief and get your pressure set at the same time. And typically they have barometric dampers on the relief, and they'll be weighted. And so you can, if you don't have enough If you have too much airflow and not enough pressure, then you can dial back the weights to increase the pressure in the stairwell or vice versa. And then you're going to just have to play with the speed setting until you get both of those set. Once you get all of those things set, once you get all your paperwork complete, you go through and do all the performance testing, you get all your set points fine-tuned. One of the things that we typically have done and is requested by the construction team is that we get with the fire engineer and do a dry run of the testing. And so this is now where we may have been going through and doing our testing with the fan in hand. We are now moving into a point where we're gonna activate it by the system. So we're gonna go ahead and smoke ahead. We're gonna go through our testing, and we're basically gonna make sure that we are ready to go for the AHGA to show up, and we're gonna have no failures. So that's the next part. And then the last part of it all is that we're going to do our final testing. We're going to turn in our final documentation. We're going to do our final testing with the AHJ and the fire team, the fire engineer and the controls contractor. We'll go through, check all of the pressures, all the door forces. In some cases, you're going to have smoke evacuation as well. So they're going to want to see differential pressure from the floor above to the floor in alarm and the floor below to the floor in alarm. Those are type of the things that you may see, but those are going to be specifically requesting based on the smoke control plan. And then we turn in our final report and that gets approved. So some typical things that we have found, lessons learned over the years, and a lot of these we have already talked about, but is that schedule impact? It's the pressure to get started too early. That they want to get it started, they want to get sign off, they want to do everything they can to condense the schedule, but if the stairwell is not ready, you're not saving time, and that's a hard thing to explain to the construction team. That hey, if your stairwell is not 100% done, I promise you, we're not saving time because we're just going to have to go back and do rework throughout, as construction is completed, as doors are now finalized, as glazing goes in, as final flooring goes on, it's going to change our testing and we're really not saving time. So working with them to understand what they need to do in order to complete that stairwell 100% so they can get started is important. Some other things that we've ran into, typically stairwell pressurization fans are oversized. It's because they don't want to miss on the under, right? They don't want to miss making the fan too small because there are variables like how much leakage is out of that stairwell, in those things. So that they typically oversize stairwell pressurization fans. And so we just have to work with them, does it have a VFD? Hopefully it does. That's been now kind of the normal operation for everybody is that they have VFDs, which is easier to dial in. But we've also had to change shivs. We've also had to make some other modifications to fans in order to get the correct CFM. So that's just something to be aware of. One of the other things that we see a lot of times is that they install OBDs. So you may have 4 distribution points or outlets within a stairwell, and they're going to install those OBDs. And typically they're not the nice OBDs, they're the very flimsy, rattling OBDs. And so almost always we tell the construction team to pull those out. We don't need them because really we're just trying to set pressure in the space. And so any kind of proportional balance through those distribution points really don't affect the pressurization of the stairwell, but they place into a effect that it's a failure point. If those OBDs move, adjust, shift over time, it's a failure point that we just don't want there. So we typically have those OBDs removed. It's just something you may want to see. Relief dampers not having weights or being set correctly. It's another thing we've seen. VFD can't the VFD don't have it doesn't have a fire mode. So that's the other thing we want to just keep in mind is how is that VFD activated. We've also had before on the smoke evac side where we've needed multiple points from the VFD, depending on where we're at in the stairwell to meet the CFM requirements, and that can be problematic as well. So these are just things that you may want to be talking about with the team throughout the process. Some of the things also we've talked about in general construction is the egress door at the bottom cannot close under pressure, door hardware issues, increasing door forces, and no adjustable door sweeps. So those are all the type of things that we talked about throughout the presentation, and some things you may want to look for. So it looks like we're getting to time here, guys, and wanted to leave about 15 minutes for a Q&A session. These were just kind of the highlights of what we just talked about. So I'm going to go ahead and go through those. Skip those, and we'll get to Q&A.
All right, thank you so much, Eric. Let's see, we've got quite a few questions in the Q&A, so this is good. This first one says, you may not know the answer, but why such a focused effort by authorities having jurisdiction on pressure to open a stairwell door? If I'm in a fire situation and running out of the stairwell, you can be ensured my entire 200 pounds of body weight is going to be punching out that door. Any thoughts on that?
Yeah, I mean the limitation, absolutely. For this individual, you probably have the force to open the door with no problems, exceeding 30 pounds, right? We actually had a situation at a one of the job sites that we've actually been working at for a while now, trying to help them get through their smoke control approval process. Is that they use the return fan as the smoke evac fan for the floor. And when you turn it on, it goes to 100% and all the other dampers in the building close. And so you have 100% of the return air being sucked from a single floor, and it has caused that. I mean, it goes up to, I don't know, if it exceeds what the door force can even look at, and it's difficult to open. And so why they put such an emphasis on it is not everybody is us, right? Not everybody can shove their shoulder into a door and make sure that it opens under pressure. And so they're trying to ensure that even the people that don't have that ability can open those doors. And so there's a huge emphasis on making sure that, whoever needs to open that door to be able to get out of the space has the ability to do so. And they found that that 30-pound limit is kind of the typical or the average of what people can do. So in ADA requirements being 15, if you have somebody that needs to get into a stairwell, what we've usually seen that happen in a hospital situation, where you may have people that are frail and can't open a door at 30 pounds, they've required it to be 15. So really it is to ensure that anybody can open that door to get out safely.
All right. Next question says there are two methods for designing smoke system ventilation. Can you speak to the prescriptive code minimum airflow?
Minimum airflow. I guess I would need a little bit more of what that you're requesting. I guess the limitation of airflow that I saw was at 200 feet, or that I've come into. So the two requirements that I've seen flow being required is the IBC requirement, where you have to have the 2,500 CFM of exhaust or relief within the stairwell, and then the 200 feet per minute requirement across for any type of makeup air or transfer air that they don't want to disturb the fire. And so those are really the two requirements, and those are the minimums at which we're required. From there, for a stairwell pressurization, I've never seen a requirement that says you have to have X amount of CFM from the stairwell pressurization fan. It has always been whatever is required to meet the pressure requirements. So the pressure requirements supersede the CFM. If it has leakage within the system or the stairwell, excuse me, and you have that 2,500 CFM and I have to set the fan to 4,000 CFM or whatever, I've never seen an actual limitation or requirement for the CFM of which the fan must do, other than those 2 points.
All right. I think a couple of our questions are related, so I'm going to try to combine them into one. So, one asks about how do you address with the construction team that people can't be moving around the building during the test? And then similarly, I think this person asked, how do you maintain the positive pressure in the stairways during the smoke or fire activity when opening multiple doors at the same time?
Yeah, so two great questions. With the construction, with ongoing construction, I mean, I can't tell you how many signs we've made that are red and in your face. We put caution tape across doors. We've done everything we can to say testing in progress during construction hours, and it never fails that somebody walks in. Never fails. So that usually pushes us to after hours. So we're typically coming in after hours to do our testing to make sure that we're not getting in a situation where people are opening and closing doors because that does adjust your testing. And so you have to just deal with, that with the construction team, whether that's a change order. Hey, we didn't anticipate having to do this after hours, and now we do. But in order for us to be efficient in our testing, we really need that stairwell closed. So I've never found a great way to keep everybody out. Like I said, we've tried all different types of signs and caution tape and everything else to try to minimize that, but it always seems somebody walks across into the stairwell. So you're just going to have to work hand in hand with the team in order to make that happen. The second question, can you remind me, Cassie? The second part of that?
Yes. Let's see. How do you maintain positive pressure in the stairways
Correct.
during the activity with multiple doors open at the same time?
Yeah. So that's where that rational analysis comes in, where basically they'll come up with how many doors they expect to be open. Now, we as practical, right? Just as you said, practically and is going to be every single door is going to be open. The system's not designed to be able to overcome that and keep the stairwell positively pressurized with every single door open in the stairwell. They're just not designed that way. But you have to have a standard at some place to say this is now the requirement that we're going to try to achieve, and that comes in the rational analysis that you'll see. But the one stairwell that I did see try and overcome that exact scenario is when they tried to do it with the VFD controlling to a DP from the stairwell to atmosphere. It was very problematic because trying to control to that point one in pressure is almost impossible for a VFD to keep up with the changes that are happening with doors opening and closing. So you really wanted it to be fast, right? All these doors open, you want it to be fast to get to that point 0.01. But in doing so, you're causing all kinds of pressure swings. And so, really, what ended up happening is we had to slow down the PID loop to say, don't overreact when doors are opening and closing. And it was a very slow PID loop. But in that circumstance, then it may take a long time to, if multiple doors are open for a longer time, it may take it longer to get there and it may take it longer to back down. So I don't think that they've solved that issue yet, but it's definitely something that comes up very often is, in a panic situation, especially in a high rise, all these doors are going to be open. The system is not designed to keep it positively pressurized to the requirement, right? It may still be positively pressurized, but it's not going to be that cascading a 0.05 or that zero point 0.1 that you set it to with all the doors closed.
All right, next we have a couple of questions that ask about how you approach balancing and pressure control when a stairwell does not have relief dampers.
Uh, yeah, I mean, if it does not have the 2500 CFM, I'm thinking that's what we're talking about. If it does not have the 2500 CFM of relief, then you're just going to set it accordingly, that you're going to set the pressures to, you're going to set the fan to meet the pressure requirement. What we've seen with that 2500 CFM and why it's installed, there's multiple reasons. One is because of the increased energy that you're putting into the stairwell, it can kind of overcome some of the variables that we see if it's prevailing winds or leakage, those type of things. You're not going to see as much swing in the stairwell because you have kind of excess energy in there. Whereas you have that closed system with no relief, those type of things can have a greater effect on the pressure relationships. The second thing is, and we talked about, was having that excess energy, that 2500 CFM of exhaust. Now, when a door closes, now you have that extra CFM to, sorry, when that door opens, now you have that excess CFM of energy to go out and try to maintain that stairwell pressure. I hope that answers your question.
I think we've got time for a couple more. This one says, you emphasize stairwell construction completion being pivotal. Should we also be concerned about how much of the building construction is complete? If so, is there a minimum percentage of building construction recommended?
Yes, 100%. Why that matters so much is depending on how far the smoke control plan goes. We talked a little bit about smoke evac. So a lot of the buildings that we deal with have the floor and alarm goes into a smoke evacuation. And so we're now testing pressures from the floor above, the corridor above, and the corridor below the floor and alarm. And they want to see a zero point zero 0.05 pressure to the floor above, and they want to see a zero point zero 0.05 pressure to the floor below. And then they will have requirements for CFM, at least a minimum. They'll have a requirement, a minimum CFM requirement to evac that smoke. And so in that situation, you need all of that to be 100% complete. That's why we talk about being almost at the very end of the construction schedule, because we need that all those areas to be complete and not changing. Windows are missing. If it's very hard to create a negative pressure if you are just open to atmosphere. So you need that to be complete. Uh, you know, so is there a minimum requirement? I don't think so. What I was always hope for is at least the envelope is 100% done. And then depending on the smoke control plan, I'm going to be looking at spaces to see where they're at in construction and really emphasize that those spaces need to be 100%. Because, what we see in high rises, or let's say a student housing, for example, we've done those before. If you can close all the doors, but they don't have seals on the bottom, it creates a different pressure above and below, because you're identifying that corridor as what we need to look at from the smoke evac side. And so those type of things, I mean, it is imperative that you're as close to the end of construction as possible, because they will change. And then typically, it always happens, right? Is that all of a sudden you do all your testing, and then whatever that day, and they put all the flooring down, or they put all the sweeps in, or they do something at the end of that first day. They finally put all the glazing in, and then they go to test with the AHJ, and it's like, well, now it's all different from what you tested. So you really need that final condition so that nothing's going to change as you go into testing.
All right, we're gonna do one more question and then wrap up. This says, what is the requirement of the TAB team to support system FPT and IST for stair pressure systems?
Great question. Say that one more time, Cassie.
What is the requirement of the TAB team to support system FPT and IST for stair pressurization systems?
Uh, so one of the things that I was talking about is not our job to design the system, right? So we're not the designers. We're not the ones putting together what the requirements are. We're just doing the testing. And typically, all the testing that is required by us from a tab contractor standpoint is going to be in that fire smoke plan. And we're adhering to basically the fire engineer to say, hey, we're going to meet these requirements. So we're just doing the testing. Like I mentioned before in all of this, is that really being a team player in this scenario, because you're all in it together. It's not like they're going to sign off on portions of the smoke control plan. It's not like, oh, hey, as we did this, as we went through the stairwell pressurization and we tested all your door forces and your pressures, the sequence didn't happen correctly, right? Well, I've had elevator doors not close because the fans started too early, or the fans kicked on for the smoke evac, and then the door started to close. And so when it did that, it created a negative pressure in the corridor and kept the elevator doors open. Well, that has nothing to do with the test and air balance, right? It's nothing that we've done to cause that. It's because of the sequence. And so they had to put sequences in that says, okay, there needs to be a 5-second delay between when, okay, alarm happens, 5 second delay to allow the doors to close. Now we're going to kick on the smoke evac fan. And does that, should we be a part of that? Or do we have to be a part of that? We don't. As the tab contractor, really, we don't need or have to be a part of that. But what I will encourage everybody is we should we as a team player we should want to be a part of that because as our success goes for the project, it's whether we're going to all pass together or we're all going to fail together. They're not going to just sign off on our portion of the smoke control plan. They're going to sign it all off together. So being a team player is extremely important as you go into smoke control testing.
All right. Thank you so much, Eric, for an excellent presentation and discussion today. Thank you to Integra for supporting this session and as our sponsor. And thank you to everyone for joining us. We hope you found this session insightful and full of takeaways that you can bring back into your own work. Before we wrap up, I want to encourage you all
Thanks,
to
man.
join us for some exciting events in 2026. On March 9th, AABC will host an in-person TAB seminar in conjunction with NFMT East 2026 in Charlotte, North Carolina. You can find more information about that at aabc.com. And from April 21st to 24th, 2026, we hope you will join AABC, ACG, and EMA in Chicago for CX Energy 2026. Registration is open now at cxenergy.com, and you can save $100 on registration if you register before the end of the year with code SAVE100. All that said, thank you for joining us for AABC webinars this year. Happy holidays, and we will see you in 2026.